Hello, Alex. It's great pleasure to see you today, and it's been a really great announcement that you just made regarding the discovery, and so I'm dying to learn more about this thing and how you got there. So let's start with some personal story. I know that you are from a very cool background, combining computer science and biotech, and you hold a lot of executive positions in tech companies, and then suddenly you switched to biotech and started in Insilico. So how everything worked out? How did you start that project?
Thank you, Andrei. Great to be with you today and address your audience. I must say that you are following our industry and also our company for quite some time. I think since 2015 or 2016 when you first wrote about it and about the upcoming hype in our industry and hype turning into reality. So great to be here. By the way of introduction, so I did my first two bachelor degrees in Canada at Queen's University. So one at Queen's School of Business and another one in Arts and Sciences and Computer Science. And then worked for a number of semiconductor companies. I also worked at ATI Technologies, which makes graphics chips and which competes with NVIDIA. Now it's part of AMD. Back then, it was actually much more competitive with NVIDIA than it is right now. So NVIDIA is, of course, a dominant force on GPU, and it powers the deep neural networks that we're using today. So for me, kind of very early in my career, I managed to make some money on the stocks in semiconductors. So ATI got acquired in 2016. So I managed to make enough money to sustain myself for a few years, and thought, okay, well, what I'm gonna do next? And should I go back into IT and continue in the rat race, making money, or should I do something more impactful? And my one of my major interests from the very early childhood is aging research. So I just do not want to accept the grim fact that we reproduce, we take care of our young, we reproduce again, and then we take care of our young and gradually decline and die. So it's kind of natural order of things, but it's kind of cruel to the people who need to decline and die. And if you think about the marginal contribution of curing any single disease, like for example, if you completely cure cancer, if you eliminate just cancer, it adds 2.6 years to life expectancy in the States. That's the current consensus estimate, or 1.3 years at age 65. That's 2.6 at birth. So it's actually a very marginal increase, right? So you can basically add a year of quality life to people over 70 if you completely eliminate cancer. But it doesn't really change the picture. And you really need to look deeper and look at aging. So I decided to go into biotech and apply the computer science approach to problem solving, to try to deconvolute the very complex process into many less complex processes, and try to see if we can solve some of those processes to make a bigger dent in the big process. So I did my grad work at Moscow State University and at Johns Hopkins as well, and then worked for a number of biotech companies, and then started my own lab in academia in cancer biology, cancer bioinformatics, looking at the very different types of cancers. And I realized that when you're looking at cancer, you are looking at pretty much like a nuclear event, post-apocalyptic city, for example, right? And you are trying to either remove that city from the planet and to be able to build something new, or you need to reconstruct it. And you also are comparing, post-apocalyptic city to another post-apocalyptic city. because there is so much that has changed in cancer cells. It's very difficult to rescue them. And I started applying more aging research concepts, looking at data longitudinally. So over time, comparing young, old, middle-aged, and kind of all ages in between, trying to train different algorithms to predict age and track age using biological data to see if we can train any kind of machine learning system on age prediction, to predict age, and then to see if we can deconvolute that knowledge of human biology that is predictive of age into something that is more related to disease. And if we can find some relevant targets or pathways there, it was kind of a shotgun approach. Also in between, we looked at multiple different biological processes that transpire during aging, published a number of papers. And then in 2013, one of my friends from NVIDIA, so some of my ATI colleagues, they kind of migrated to NVIDIA. He invited me to GTC, so graphics technology conference. That's an annual conference by NVIDIA. And I met a lot of people there who were my former colleagues, former classmates, and they told me about deep learning. And at that time, of course, knew that quite a bit about neural networks, but at that time, 2012 to 2013, it was just the beginning, and only after deep neural networks demonstrated really amazing accuracy in image recognition in ImageNet, the deep learning revolution has begun. And at that time, I realized, if deep neural networks are so good at image recognition, why don't we use them for age prediction? And maybe then we can look at various ways to derive biologically relevant features in those trained deep neural networks. And that's where our story began, right? So I applied my knowledge in other machine learning techniques and bioinformatics. And at that time, I already had quite a bit of experience working with all kinds of data types and with all kinds of diseases, and ran my own group. So we started developing a range of algorithms that, reduce dimensionality of data for this purpose, allow us to train deep neural networks on smaller data sets, identify most relevant features, deconvolute networks into features. And by 2014, we had quite a bit of experience in that, and we started a company, so Insilico. So Insilico was originally started as a target discovery company from the perspective of aging research and age-associated diseases. And then we went into chemistry and then combined chemistry and biology to get where we are today.
It's interesting, actually, because aging research sounds like a more complex area than the actual, therapeutic discovery. Because, and then you actually started with aging and went into therapeutic discovery somehow. Interesting. But so I see you're really obsessed with AI, and I know you even wrote a book about the a robot, how to understand the robot, and the relationship with kind of imaginary AI person. There is a nice stuff actually, and but I see your obsession with AI, which started basically as obsession, it actually grew into a real thing right now, as now you seem to have discovered something really big, applied AI to find out a new target and a new molecule active on that target, which is, to me, is amazing. But do you think this is like a major shift in the way the drug discovery is done, or it is like very opportunistic thing? What's your opinion about that?
So I think this time it's a major shift. So we already did quite a bit of those opportunistic incremental improvements and some opportunistic movements in both target discovery and small molecule chemistry. You probably remember our work with a company called BioTime that we published in 2017, but we did the work in 2016, and unfortunately, they had to spend quite a bit of time on experimental validation and then patenting, and then lots of bureaucracy in terms of publishing. So we didn't publish in a top-tier journal, but it's still it's a traceable publication, 2017, where for the first time we published an application of a deep neural network to target discovery. So we've identified an embryonic to fetal transition factor called COX7A1. So that was more or less an opportunistic paper and opportunistic work. We actually got paid for it, but very little. And Biotime spun off the entire company called Ajax and took it public. And a very substantial part of IP was that COX7A1. And we've identified a few other targets during that time. So using very large data sets of transcriptomic data coming from embryonic stem cells that were differentiated from mature cells. We actually use very similar approaches to target discovery in many chronic diseases like fibrosis. And then we have a number of papers that were also quite opportunistic on generative chemistry. So our first one was in 2016. So we did the work in 2015, 2016, early 2016, submitted in 2016 in June, and then published in November 2016. That's where we showed, it's called the cornucopia of meaningful leads, where we showed that we can now generate molecules with desired set of properties, but we had to match them back to the chemical space. And then we published a number of papers in theory where we could generate molecules with the desired properties and synthesize them de novo. And then we did it for the first time in 2018 and 2019. You remember our kind of reasonably famous paper in Nature Biotech, where we actually synthesized and tested all the way to mice for a very well-known target, old target. But we managed to do it very quickly nonetheless and synthesize. And it was a very neat experiment which was timed. So, and we were talking about days, not months, not years. So that was pretty cool, but that was still opportunistic. And in order for us to convince Big Pharma that this is a paradigm shift, we would need to, I knew that we would need to take something into clinic ourselves. So, and we would need to do it also for a novel target, not a known target, and do both biology and chemistry, and then digital medicine as well, because now I'm designing a clinical trial. We are going to use some things that people have not used for clinical trial before. For the first time, I think that Big Pharma is going to be convinced, right? Because every big pharmaceutical company has invested dramatically into artificial intelligence. So some of them hired 600, 700 people to focus on data science, on AI, and that's in addition to what they had before. And many traditional bioinformatics and cheminformatics people were rebranded as AI. And now they actually got the experience necessary to progress. However, I haven't seen any similar result coming out of Big Pharma, not a single one, so billions of dollars spent, but I haven't seen any publication or announcement that would go beyond our capabilities as a small AI company. So I think that now we really have the ability to replicate this many times over. So of course I will be doing kind of piecemeal experiments. So we will also discover targets for the others. We will generate molecules for the others like we're doing it today. But we will also do those kind of very quick rat races going after specific new targets in a variety of conditions, because that's where you generate the maximum amount of value. And once you go phase 2, those assets become dramatically valuable, regardless of how they are discovered. So people do not need to, look at under the hood and try to understand and see if they can do it themselves in order to partner. They would just take the asset. So it's much better to have those assets rather than try to convince people to partner with you. We've done this before. For us, it's not as easy. It's just like fundraising. Originally, we had to convince people to invest very little in us, right? And all kinds of people. So it wasn't an easy. We were not born into a very rich family, so to speak. We had to start from the very kind of bottom. And consistently prove ourselves in order to to partner or to get more money or to get more deals or to get some great people. So it wasn't easy. Nobody partnered with us on faith, right? You see now some companies partner with Big Pharma, get 60, 70 million dollars upfront without having any tangible targets coming out of their system before, right? So people are just partnering, doing those crazy deals on the expectation of something coming out of it. And again, for some people, the technology just doesn't work. And they get showered with cash. And in our case, it wasn't like that, as you know. So we had to show that it works. And I think that this time, it's irrefutable evidence in mice all the way to preclinical candidate and IND enabling for a reasonably difficult disease with no real cures and with a standard of care that we outperform everywhere. That is actually going off patent soon, so we can even combine them as different mechanisms of action. And I think now people will listen. And it's not an incremental release. So, some other AI companies now get a lot of attention when they claim that they solve a big biological problem, right? We don't even know how big that problem is. But in this case, for example, we managed to go around that problem somehow, right? And we only will see if other companies can really do something transformative only if we see something in the clinic, right? And even for us, I want to take this into clinic myself without a partner, just ourselves, just so that we know that there is human component and human risk is eliminated. I know that at least the management risk is eliminated, so we know that we will take it ourselves. The other people might hesitate, or they might hesitate to use the same biomarkers as we will. So I want to do it all by myself.
I see. So to me, it occurs to me that you basically started as a sort of contract research company, as many AI-driven biotechs in this space, and then now you are kind of ready to take on a more challenging thing to create your own pipeline of targets and ultimately drug candidates, and basically grow into a clinical stage biotech. To me, it's kind of building a pipeline on steroids using AI, something like that.
Yeah, so that's the idea. We hired a bunch of really high caliber people to do that now. It was very difficult to convince them in this market because, for example, in China, where we also do operate quite extensively, it's almost impossible to hire amazing drug discovery people because most of them, they're showered with cash and they start their own companies or they start from scratch. And the mantra is either, fast follower, so it's like best in class, or second in class, but for the China market, or in licensing a portfolio of clinical assets and then taking them forward. And then, of course, to spice it up, they also start preclinical research. So right now the market is very hot and it's very difficult to get really brilliant people. And we managed to get some of the best in the world. So we also have humans with a lot of experience with demonstrated capability of taking hypothesis level molecules all the way into clinic, but over a very long period of time. And also in contract research organizations for doing the same for the others. So we can now take our programs forward ourselves. So not as a bunch of AI guys, but as a bunch of AI guys and drug hunters. But we are AI first, so it's a little bit different than other companies that start with a drug discovery team.
I have an interesting thought here that, in my opinion, like I have been reviewing a lot of AI companies over the last several years, and it's easier probably to build in the AI first R&D company from scratch than than actually transform a big pharma corporation into this kind of stuff. Is it actually the case?
I think so. I think so. So I cannot agree more. Some pharma companies would disagree. Some pharma companies would agree, but say that, you know, we need those capabilities ourselves. What is very strange is that, you know, we've been on the radar of many biotech, of many pharma companies for a while. And, you know, a year ago, or maybe 1.5 years ago, some of them could have bought us for very little, right? So if one of them would have come to me and said, Alex, you know what? We got those coffers of data. So here is a data lake, right? And we're gonna buy you, and we're gonna put your guys, your, you know, ninjas who were picked using hackathons and competitions, who know how to solve very complex problems very quickly, and actually had demonstrated and published capabilities. Why wouldn't they produce really great results based on the data that, you know, Big Pharma has? But nobody even you know, thought about that. Or maybe they thought about that but decided otherwise. And now they're like heavy trucks piloted by, you know, robots that they created themselves. You know, if you're a Mack truck, you don't see a lot of driverless Mack trucks, electric driverless Mack trucks out there, right? So it's very difficult to transform. But there are some others like Nikola or Tesla and many others in China. It's already reality. It's much easier to start from scratch. So I would compare it to automotive. And now you see that some of those electric giants, they are valued at higher valuations than, you know, the older school gas guzzling giants. And I'm not sure for how long it's going to stay like that, but if the trends continue, we will hopefully see something like that in pharma. I'm not necessarily saying that it should be us, but I think that pharma companies should focus on what they're good at, right? So that's clinical trials, and it's ensuring that the market is satisfied with the right products. So manufacturing, sales, and the innovation should be outsourced as much as possible, right? Because of course, you know, great pharma CEOs, they're not great at building internal R&D pipelines, right? It's not what is generating a lot of shareholder value. It is ensuring that your phase 2, phase 3 pipelines are full of really amazing assets. And I hope that we will be able to contribute to that, right? So now we're basically surveying the market of what for what is going to be hot 5-6 years from now, and trying to get into the trend and ensuring that we can now generate those molecules and identify those targets much faster to satisfy the Big Pharma demand 5 years from now. So yeah, I don't think that Big Pharma will be able to outperform. It's even like I see very often cases where AI guys in Big Pharma get very frustrated when it comes to generative chemistry, for example, because their molecules do not get synthesized and tested. They have the budget sometimes to do that, but they do not have the ability to fail a lot. So for us, for example, when we were developing our generative pipelines, when we were validating our models, we were failing a lot. So on purpose. So to generate the data, to understand what works, what doesn't, to see which approach is better. And sometimes the contract research organizations would call us and say, hey, Alex, you know what? You probably don't have a good medicinal chemist. So can we help you? Because the molecules that you sent us are just weird. So they are very difficult to synthesize, and they're just, the probability of they're going to work they don't satisfy any of our, of a requirement for good molecule, I'm saying, please just synthesize and test. I just need you to give me, the activity data, and I want to see selectivity. And they're like, interesting. And I test, and they look at it, and they are like, okay, well, maybe we want to invest in you now because we are mistaken, right? Or they would say, oh, here is the data, right? But why are you doing it, right? But the fact of the matter is, we are doing it to calibrate the models. So most of the pharmaceutical industries, AI guys, they don't have that capability to synthesize and test. But at the same time, when a therapeutic area head wants a molecule, they would always trust their medicinal chemists and computational chemists maybe, but most medicinal chemists to design the right molecule and the right candidate. So we actually when we started selling our Chemistry 42 software, we realized that we are solving a huge problem. So we're actually allowing the AI guys in Big Pharma to go train their models, plug it into our Chemistry 42, compare it with everything we have done, and also generate the molecules for medicinal chemists that make medicinal chemists happy, that medicinal chemists do not vomit when they see the molecules, right? Because sometimes, a very good medicinal chemist really sees good and bad chemistry. So you and I, we cannot do that. I don't know about you, you work for also Enamine, right? So huge supplier of chemistry. But some of my guys, when they look at the molecules, they are like, wow, okay, this is great. I'm like, okay, well, tell me why. And they can describe why. But when the AI starts generating complete crap, and we see the publications from many other teams that do not satisfy medicinal chemists, they look weird, right? And you don't want to show those molecules that look weird before you show them the good ones, right? It's actually good to synthesize a few of those weird ones, because you need to go outside the general kind of human norms. If somebody were to invent tropomyosin from scratch, it's a huge molecule, right? That you really want to have more of, but it's very difficult to invent something like that from scratch, right? It's nature. So unless you manage to show medicinal chemists something that looks great, they would not synthesize something that doesn't look great. And our system allows to do both. So you can prioritize novelty, you can prioritize standard medicinal chemistry practices, and you can satisfy both camps. Actually, you can satisfy 3 camps. You can satisfy medicinal chemists, computational chemists, and AI guys. Currently, those areas are quite disconnected in Big Pharma, yeah.
Yeah, so it sounds like your AI is actually linking chemistry, biology, and everything together, and creating an end-to-end the drug discovery system or process, which is not available. I'm not quite sure it is available anywhere else, or maybe I'm mistaken. Mostly, I know startups that they apply AI for certain areas like docking or screening, target discovery separately. But a lot of them that actually build something that connects the dots, so to speak.
Well, again, I think that a lot of people claim nowadays that they have something like that, because we do. And as you know, when investors do their due diligence on some other companies, they are asking, okay, well, Insilico is doing that. Can you do this? And they say, of course we can, right? So here we hired a couple people, and let us put it on the slides, right? So it's in the slide deck, and then maybe a couple announcements, but there is no really tangible published work, for example, in that area. And there is no tangible published results, something that I can feel. And I know that, in some places it's just not happening. It's there for the purposes of fundraising. And it's actually quite sad sometimes, because you realize, like sometimes, especially in some regions, I'm not going to name which ones, because I'm operating there a lot. But there is a revolution of AI companies. Every professor is starting an AI company in drug discovery, and very often, we go to a trade show, we walk into somebody's booth, and there is a nice picture, nice diagram on the wall, and it comes from my paper. And sometimes it's like minor modifications from a paper that I wrote, and I come to the head of AI of that company and saying, okay, well, did this model work? And she's saying, yeah, of course, it works perfectly. I'm saying, well, does it work for the targets of this class and this class? And yeah, of course, it works for everything. I'm saying, well, I know that the reason we publish this is because it works only for this particular, application. So it's not a universal model. And she's like, oh, how do you know that? I'm saying, well, I'm actually this guy. So, and show the paper. He's like, oh, can I work for you? Alex, I didn't realize, even though I'm the only kind of person with this phenotype in the show. So it's kind of sometimes frustrating, but at the same time quite encouraging, because we managed to help build the industry, and there will be a lot of fallout from those companies who are claiming to do something. Maybe they don't have that particular piece working, but they have something else. Otherwise, smart investors wouldn't give them money. And I think there will be convergence over time, and you will see more and more of those end-to-end boxes. It's just ours, to my knowledge, is the most experimentally validated, right? Because we have published not every, but many single pieces, at least at the POC stage. And now we brought it all together, and now we got it working so that we got the preclinical candidate and the IND enabling study going, right, for a broad disease indication. So I deeply respect many others, like, for example, Brandon Frey's Deep Genomics. And this guy's, specifically Brandon Frey, so it's a hugely respectable name, at least in my book. And they managed to also do a preclinical candidate, but for actually a while ago, but for a monogenic disease, they identified using genomics data, and then generated oligos, right? That's not a small molecule, to fix it. And so in my book, again, it's the order of magnitude or several orders of magnitude more or less complex problem, and of course smaller disease, but still it's the first nonetheless. So they deserve praise and recognition. But many others, they did not go that route, right? So it's just a press release with nothing, or just hype. In our case, we tried to publish quite a bit of our stuff, even though we didn't need to. But now we can basically tangibly say, okay, well, this technology check mark, here's a paper. This technology check mark, here is a Nature Communications paper with top KOLs. This technology check mark, here you go. Nature Biotech, you can check like at least the general direction. This technology check mark, right? So here, generation to a specific transcriptional profile, and here is a patent that's 2 years before the paper. So it's the roadmap which we created over time, and we will stick to that. So we'll try to continue publishing. In our current case, with the PCC announcement, we decided to actually show a documentary, right? So how we did it, and outline this with a story, provide a story how we did this with the different papers, because most people don't even realize they don't cite our papers anymore, because they're looking at 2020. And okay, in 2020, Insilico did not publish in that area. Okay, let's not cite anybody. So yeah, we're the discoverers. And it's actually quite frustrating, because a lot of people do not work together due to this fact, right? I would really love to work with some of the AI companies that are out there closer, and just for the purposes of, well, fundraising or racing for a specific purpose, they do not partner. But we are very collaborative. And actually, one partnership I would really like to highlight is Arcturus. So the guys who do laboratory robotics, laboratory automation. So I really love those guys. And there we also had a few case studies where we sent them molecules that we generated for a range of targets just to test them out. And we paid for that. And they produced the results very quickly. So they are kind of in vitro in a cloud. So you can design pretty much the same experiments. And they got the biology to work, so we like those guys a lot. And we like to partner like that with the others.
Wow. So it seems like you're not just discovering cool stuff, but also building a community. That's impressive. I'm convinced that we are at the beginning of something really big in this case, a big change, and the AI will be in the center. So to summarize our interview, I'd like to actually ask your opinion on what do you think is going to happen in this year? Where the industry is heading? What's the aftermath of this COVID pandemic is going to be like? And what's the role of Insilico might be in all this new future of the biotech industry?
Well, I think that the future of our industry also depends on the state of the general economy, because the economy is not behaving rationally right now. So I'm just looking at the global economy, and I see a lot of inefficiencies, and a lot of people are staying at home. People are not driving. People are not, doing a lot of useful work. Farming is going down. Everything is going down. No production is going down, but the stock market is going up, right? And countries are printing money like crazy. There are many restrictions on doing business, so the economy, in theory, is in a very depressed state. For at least for some areas are on complete life support, and I hope that the state of general economy does not really affect us. So I see that there is a major tide in a major increase in money supply, and good and bad companies get the funding, and more bad than good ones. And it's just, I hope that this mad ride in the stock market is not going to lead to some crash that will inhibit innovative businesses like ours, right? Because if there is, blood on the streets, and people are striving to find, food and shelter, they do not care about drug discovery, right? And many of those projects might be buried. If the economy continues to grow, or there is a mild landing, I think companies like ours are going to do very well, because we've got an arsenal of tools, those picks and shovels, to support the others. But we also have our own gold mines now that we're developing. So those gold mines are going to open up in time. So we're going to pass the phase 2s. And we're going to start licensing, and those products are going to propagate to the market, and we're going to help a lot of people. And as more funding and more attention is focusing on our industry and on our company as well, we would be able to do more with those resources, right? So I will be getting into robotics in a very dramatic way, a very different way compared to everybody else. It's completely different data type, completely different approach, completely different people, and very scalable and very cheap architecture. So I expect a lot of discoveries to come from that. I think a lot of people are going to pivot into robotics now, right? Because that's the only way to prove that you are not using a human anymore. And you are allowing some processes to be completely run on autopilot. So we want to get there. I think that once I get a little bit more resources, I will be able to go after aging in a little bit bigger way, specifically age-associated processes. So, I'm going after fibrosis, we also have to go after some kind of quicker wins and safer bets where you have a very complex but known target, and maybe in cancer, in immunology, in synthetic lethality. But we, of course, do not give up on aging, so because that's my life. And we have many projects in that area. So with more resources, we would be able to go after more chronic diseases and maybe repurpose some of the molecules. So I think that from this standpoint, if you completely abstract yourself from the general state of the economy, the outlook is very good for the industry, because many other companies like ours, not like ours, but maybe in different segments of drug discovery like ours, they got the resources, they got the attention, they got the people, and it's the early days of, it reminds me of the early days of the internet, right? So you've got a lot of .coms, but there are some, Amazons and the Googles and the Yahoos of the world that are striving and that are going to be taking the leadership positions. And I sincerely hope, but believe that we are one of those companies. So we want to be the Amazon of our industry, and the Google and the, and Alibaba and Tencent. So those companies did not exist, before the internet revolution. And back then, I also remember I was in semiconductors at that time. I remember those crazy projections that people were, selling to the investors. And I had the same feeling as I have right now. That, you know what, guys? Sorry, I do not subscribe to those. And 20 years later, they not only achieved those objectives, they exceeded them many times over. So I hope that we will see the same in our industry. I need to stay optimistic. And COVID or not COVID, we need to push and we need to do more. And if you think about, so if anybody calls hype with what we are doing now, sorry guys, it's a preclinical candidate. You cannot get around that. It's not just some algorithms we published, right? And second, if somebody calls hype still, we can say that, hey guys, you know what? Let's ensure that you do not have, Kardashians or Trump or something else on your Twitter feed or Google feed, because that's hype. That's something that you can live without. But you cannot live without drugs. So, the more hype, the merrier. We do not promote it, but we would not resist it. And that's kind of stupid to resist it because, the last time DeepMind did AlphaGo, it made 1.2 billion people go into AI, or at least learn about it. So that's a very positive thing, and it promotes the spirit of positive. So I don't care. I want to make people feel positive, and I'm very positive. So we need to believe that the future is better than we think.
Wow. Alex, thank you very much. It's actually very inspiring to hear this kind of forecast, and let's hope that the industry will stay resilient to all this, obstacles and the times that we are going through, and that the COVID or anything like that will not go in the way of progress that you're making with your team. Thank you very much. It was a great pleasure of mine to talk to you, and good luck.
Pleasure. Please continue what you are doing, because I think that you're also kind of under-recognized jewel in pharmaceutical analytics, because you come from that background and cover quite a bit of industry segments. So very happy to see that you were covering us. And thank you, Andrei, and very happy to be on your show.
Yep. Thank you. Bye-bye, Alex.
Pleasure. All right.